This section is about addition and subtraction of rational functions, which just means adding and subtracting fractions. By definition, you can add or subtract fractions if there's a common denominator, just by adding or subtracting the numerator. The only problem is most of the questions you're going to have will not have common denominators, so we'll have to make them have common denominators. That's done by using the least common denominator. In the first example, the two numbers are 2 and 3. Those two numbers have nothing in common, so I'm going to go ahead and multiply them together. That new denominator would be 6. But if I'm going to make the denominators equal 6, I'll have to change the original fractions to be what's called equivalent fractions. These two have to be the same, and these two have to be the same. So we need to think about what was done to the denominator. In the first fraction, I multiplied it by 3. To make it be equivalent, I'm going to multiply the numerator by 3 to get 3/6. In the second fraction, I multiplied by 2. So I'll do the same thing to the numerator to get 2. Now that there's a common denominator, I simply add the top and use the same denominator to get 5/6. Same thing's true for the next one. I need a common denominator, but 4 and 5 have nothing in common. So I'm going to multiply them together to get 20. In the first fraction, making it equivalent, I multiplied 4 times 5. So I'll do the same thing to the numerator, or 5. In the second fraction, to go from 5 to 20, I multiplied by 4. I'll do the same thing to the numerator to get 8. Now add them up. 13 over 20. This idea of equivalent fractions is going to be true even when we have variables a little later on. Okay, let's practice some additional examples. Here's a subtraction problem, but the same thing will be true. I need a common denominator. I need to think of a number, the smallest number possible, that 8 and 12 both divide evenly into. To find that common denominator, I always start with the largest number and start working up. 8 doesn't go into 12, so let me go up another 12 to 24. 8 does go into 24, so that's the one I want to use. In the first fraction, I had to multiply the denominator by 3. In the second fraction, I multiplied by 2. Now subtract. Here's another example. This one gets a little bit more difficult because the numbers are larger. The least common denominator will be the lowest number that both 18 and 24 divide evenly into. I'll start with the biggest number, so I'll start with 24. 18 doesn't work, so I'll go to the next one, 48. Still, 18 does not divide into 48. Next one, 72. 18 actually divides into 72. So that will be my common denominator. For the first fraction, I need to figure out what number times 18 gives me 72. That number is 4. The second one, 24 times 3 gives me 72. So I have 20 over 72 plus 21 over 72, which is 41 over 72. Now you try these two examples. Stop the video, try it out, see if you can find those common denominators, create equivalent fractions, and then subtract and add the problems. Check your solutions. In the first one, the least common denominator was 70. The answer is negative 1/70th. In the second one, we had to go really far. This one took me a while to figure out. The least common denominator, none of these numbers worked as I worked my way up of multiples of 14 until I got all the way up to 56. So that one took a while. Now let's look at some things that are a little bit more challenging that don't quite follow the same pattern. Like this first problem where we have a number, a whole number, an integer, plus a fraction. What we want to do is think of this as a fraction. So the common denominator would actually be 5. That means the second fraction will not have to change at all. It already has the denominator of 5. But the first one does need to change. And we'll get negative 13 over 5. So when you see a whole number, just write it as that number over top of 1 and get a common denominator. Now things get a little bit more challenging. We're going to go ahead and start having variables as the denominators. But just like before, these two fractions have nothing in common. The denominators are completely different. So like the first example we did, we'll have to multiply those together. My denominator will be x times y. The first fraction, to make it equivalent, I had to multiply the denominator by y. So I'll do the same thing to the numerator. In the second fraction, I had to multiply by x. So again, I'll do the same thing to the numerator. This answer is going to look a lot different. It won't be a number anymore. It's going to be an expression. I'll add up the numerators, 2y plus 3x, keeping the same denominator. This is the simplified answer. Even though it looks really large and unsimplified, that's as far as we can go. So we'll leave it right like that. All right, let's try another one. This time there's a combination of letters and numbers. So when I try to figure out my least common denominator, I'll have to include both. I want to make sure that I look at 12 and its multiples. So I'm going to go all the way up to 24. But then I also need to include this x and this y, since there's nothing in common. So the least common denominator will be 24 x times y. To make the first fraction equivalent, I have to multiply by 3 and y. To get 9y. In the second fraction, I'll have to multiply by 2 and x to get 10x. Adding those two together, 9y minus 10x, all divided by 24xy, gives me the answer. Try this next one. Okay, check your work. In this one, the least common denominator number will be 12. But I'll need to include the A, the B, and the C all in the least common denominator. Now these fractions will be equivalent. Next thing we're going to look at is simplifying numerical expressions. It's basically large expressions with all fraction values in them. We have to remember order of operations for this. Very important. So the first thing you need to do in this one is not the addition, but the multiplication. Now from the last section, we learned that multiplication, you multiply straight across the top and straight across the bottom. So I'm going to recopy the 3/4 and then look for any simplification, any cancellation. These 3's will reduce. So by multiplying straight across, I'll get 2 times 1 over 1 times 5. Now likewise, in this last multiplication, I look for anything in common, and there's none. So I'm going to go ahead and subtract off 1 times 1 over 2 times 5. This has now produced 3 fractions. They need a least common denominator. Start with the biggest, which would be 10, and look for multiples of 10 then where all of the numbers go into. 10 doesn't work, but 20 will. For the first fraction, we'll multiply by 5, the second one by 4, and the last one by 2. When we put these all together, 15 plus 8 minus 2, I get 21/20. Try this one yourself. Okay, check your work to see how you did. In this first part, remember, when we see a division symbol, you have to flip it, or what we refer to as multiplying by the reciprocal. So before I did anything else, I went ahead and rewrote 3 divided by 5 times 5 divided by 8. That's what you see right here. Those 5's cancel, and so I was left with just 3/8. Once again, it's important that we go by order of operations. This next operation should be the multiplication. So I got -1/6, and now I can add them all up. The last few examples we're going to do are just some different things you can try with arithmetic. In this first one, we have a couple different options, and that's what we want to practice. So in this first one, let's actually practice distributing. The options I'm speaking of is we can actually, for order of operations, combine these two together first. But again, let me show you some alternatives. I can distribute 12 times 1/3 plus 12 times 1/4. Since 12 is technically a fraction, it's over 1, I can do some cancellation. Three goes into 12 4 times. 4 goes into 12 3 times. And I'm left with 4 times 1 plus 3 times 1, or 7. This kind of avoids the whole idea of getting a common denominator inside. So something to think about. Here again, in this next problem, we could go ahead and distribute the 5/8, or you could simplify what's inside first. Let's do something different on this one. Let's actually do the simplification in here first. I'll need a common denominator, which in this case will be 6. inside the parentheses, I just found a common denominator and made equivalent fractions. They add up to be 5/6. So to finish this, I'll multiply, no common denominator needed. Just go straight across the top and straight across the bottom. It's two options, either distribute or perform order of operations and do what's inside the parentheses first. Your choice, whichever seems easiest. The last problem we're going to do is just combining like terms, and it just so happens that they involve fractions. These are all x's. If you would have seen a problem without denominators, like 1x plus 2x minus 3x's, you would have added up the coefficients. So that's exactly what we're going to do here. I'm going to add up the coefficients. All right, I need to find out what 1/2 plus 2/3 minus 3/4 equals. That'll be the coefficient of x. Okay, they need a common denominator. I'll start with 4 and work my way up. They don't all go into 4, not 8, but 12 works. Making some equivalent fractions, the first one gets multiplied by 6. The second one multiplied by 4. And the last one by 3. Now we can add them up. 6 plus 8 minus 9 is 5. So I have 5/12 x. All right, try the assignment now.